Okay, so in this question we need to use the variation of parameter method to solve this non-homogeneous system, right? Okay, so first of all, this is our matrix A, and this is our function f of t, right? Okay, now first we need to find the eigenvalues of the matrix A, right? And here we need to write the matrix in the form of A minus xi, and here x, that is our eigenvalue, right? And after simplify this we can get this matrix, right? Now for this matrix we need to take determinant d is equal to 0, right? So we can find the value of x, and that is our eigenvalue, right? So we can take here determinant is equal to 0, right? And how do you find the determinant of 2 by 2 matrix? So we need to multiply these two terms minus these two terms, right? Cross multiplication. Okay, now simplify this. Here x square minus 2x plus 1, so we can write x minus 1 whole square, right? And we need to take a square root on both sides, right? So on the left hand side we have only x minus 1, and our eigenvalue will be x is equal to 1, right? Now for the eigenvalue x is equal to 1, we need to find the value of A minus xi, right? And that is this matrix, right? Now for this matrix we need to write homogeneous system Ax is equal to 0, right? So this is our homogeneous system. From the first row we can write 2x plus 2y is equal to 0, right? And eventually we can write x is equal to minus y, or we can write y is equal to minus x, and y is equal to y because y is free variable, right? Which means you can choose any value of y, right? So this is our solution, right? So x is equal to minus y and y is equal to y, right? And here we can factor out y. So this is our eigenvector, right? This is our eigenvector. Now okay, here the matrix has only one eigenvalue, right? So obviously for 2 by 2 matrix we have only one eigenvector, right? So but we need two eigenvector, right? So for the second part we need to find the generalized eigenvector v2, right? So here we need to write this matrix over here, and we need to write eigenvector v1 over here, right? And again from the first row we can write 2x plus 2y is equal to minus 1, right? And here we need to subject the x variables, so x is equal to minus y minus 1 by 2, and again y will be free variable, right? So our solution is x is equal to minus y minus 1 by 2 and y is equal to y, right? Now for simplicity we need to choose y is equal to 0, but you can choose any value, right? So our eigenvector will be minus 1 by 2 and 0, right? So let's say this is our vector v2, right? And this is our generalized vector, right? So this is our generalized vector v2. Now for the homogeneous system the complementary solution is given by xh, right? So this is the standard form, right? And this is only apply for only one eigenvalue, right? If the matrix has two eigenvalue, then this will not be applied, right? Now substitute the value of x, v1 and v2, right? So we can write this, right? Now you need to again simplify this, so we can write this. Now we need to find the fundamental matrix M, right? So e raised to t multiplied by minus 1, that is e raised to e raised to t multiplied by minus 1, so we can write minus e raised to t. E raised to t multiplied by 1, that is e raised to t. Here e raised to t multiplied by minus t minus 1 by 2, and here e raised to t multiplied by t, so we can write t into e raised to t, right? So this is our fundamental matrix M, or here you can factor out e raised to t also. Wait a minute. Right, so here we can factor out e raised to t. Now we need to find the inverse matrix of M, right? And this is our inverse, this is our inverse matrix M inverse, right? Now we need to find the particular solution, right? So particular solution is given by this equation. Now substitute the value of M, M inverse, and f of t, right? Now we need to multiply these two matrices, right? And here we need to find the integration of these two equations, right? So this is our first equation and this is our second equation, and don't forget to multiply here e raised to minus t, right? So this is the integrated function, right, that you can solve by your own, right, because the length of the video will be more than 15 to 20 minutes. Now we need to multiply these two matrices, right? And here you can see that here we can factor out e raised to minus 2t, right? And here we have already e raised to t, right? So e raised to minus 2t multiplied by e raised to t, so we can write here e raised to minus t that we have written here. And after multiply these two matrices, we can write here. Now we need to find the general solution, and it is given by this equation. Now substitute here complementary solution and particular solution, right? So this is our final answer, right? Thank you.